Hey everyone, my name's Mr. Boyden. I actually got a chance recently to collaborate with an IB science teacher who I work with, Mr. Kagochi, and a lot of his students are working on some data analysis. So I made up an example here. Let's see if this is useful in your situation. The research question that I'm starting with is, does the time of year have a significant effect on the flight speed of geese? And notice it says a significant effect. Not just does it have an effect, but is that a statistically significant effect? And so the idea is that, maybe geese would fly at a different speed in the winter than in the fall or something like that. So what's my research methodology? I'm going to record the speed of different flying geese in each season, and we're going to analyze the data and see what we can come up with. And so just to be transparent here, I completely just made these data up. These are not based on, I did do a quick Google search, and geese, it turns out, fly really rapidly, as fast as 60 miles an hour, which is amazing if you think about it, that an animal can go as fast as we drive on the freeway sometimes. But anyway, these are my fabricated data down below here on the left. And so these are different speeds that were recorded. And I also recorded for each of these, for fall, winter, and spring, the average and the standard deviation of those data points. And so just a really quick analysis, it looks like probably geese, at least in our sample, the geese were flying faster in the winter and a little bit slower in the fall and a little bit slower than that in the spring. So what more is there to say, right? I mean, you look at that and you say, well, geez, they're faster in the winter. Well, because we have such a small sample, like I only had 1, 2, 3, 4, 5, I only recorded 7 speeds of geese in the winter. And so maybe I just happened to only get the geese that were flying fast that day, and that skewed my result. So the question that we're really asking when we're trying to find significance is we want to ask, for these two numbers, 45.7 and 51.3, are those two numbers far enough apart that we can feel confident that, in fact, for the population of geese, they're going to fly faster in the winter than in the fall? And the way we do that, anytime we're dealing with an average or two averages that we're comparing, we're going to use what's called a t-test. So all we do is, in Excel, you have to type equals first and then let it know what you want. And the command in Excel is t.test. And so notice right below it says it returns the probability associated with a student's t-test. And so that tells me, okay, yes, that's the right test. And I'm going to use parentheses. And now, all of a sudden, Excel's going to give me a little hint here. It tells me what I need, what information I need to give. Array 1, what that means is, what is your first set of data? And for me, I'm going to compare right now the fall versus the winter. In fact, let me move this because I want to be able to label it. T-test. All right, first array. So all I'm going to do is click and highlight that information. That's my first array. So fall. Press the comma button. Now it asks for array number 2. And I'm comparing fall versus winter. And so the next thing I'm going to highlight are the winter data. And one of the cool things about this test is, even though I have a different number of data points for fall and winter, it will still allow me to compare the fall and winter averages. And it's going to weight that in here. And it's kind of doing that behind the scenes. Okay, tails. One is typically what we would use in and this is just a short video. We're not going to go way in depth on what that means. And then there's 3 options for this next one, and usually what we're going to use is 3. So guys, if you're working on your bio IA, probably these last 2, you're going to use 1 and 3 for those inputs. And then I'm going to hit enter, and I'm going to get a value back. And at first you're going to say, what the heck is that? Okay, that's what's known as a p-value. Let's talk about p-values. What's important to know is that we're going to compare a p-value to a significance level. And Mr. Kagochi was telling me that the one that they most commonly use in science is 0.05, 0.05. And that jives with what I teach my AP Statistics students. We use the same thing in our AP Statistics curriculum. It's the same thing that I learned in college, that he learned in college. It's the standard one. And here's what we do with that. Okay, if the p-value is less than 0.05, then the difference in means is statistically significant. But If the p-value is greater than 0.05, the difference is not significant. Okay, so what does that mean for us with fall versus winter? Okay, well, look at our p-value, 0.029. That falls into the less than category. So this difference is significant. That means that we're able to conclude that that difference between fall and winter is real. It actually is not probably just random chance that we're getting a higher measurement in winter as compared to fall, and that if we took many more samples out of the population, we'd likely find that, in fact, yeah, geese fly faster in the winter than in the fall. Let's run another test. Let's do fall versus spring, because we look at fall and spring up here, and we can see that in the fall, we measured a higher mean than we did in the spring. But is that difference big enough? Let's find out. Let's do a t-test. Comparing fall, comma, highlight spring, comma, one-tailed, and remember, select option 3 for unequal variance. Let's see what we get. All right, 0.1173 is my p-value. Okay, so what does that mean? That falls into this category down here. If the p-value is greater than 0.05, then the difference is not statistically significant. So, as far as me making conclusions from the data analysis here, what can I say? Based on these p-values, I can say that in fact, geese fly faster in the winter than they do in the fall. But I'm not really able to say for sure that geese fly faster in the fall than in the spring. And that might seem weird because, yeah, we measured a higher value in the fall than in the spring. But we have to be open-minded about the idea that this might just be random chance. That little difference, it might just be because maybe we just happened to pick a couple of slowpoke geese to check their speed when we checked in the spring. It's not a big enough difference for us to feel confident in the fact that fall is truly faster than spring for geese in general. So, y'all, this is just a really brief intro, but hopefully this will be helpful in seeing how a t-test could help you to answer questions of statistical significance. Once again, I'm Mr. Boyden. Thanks for watching.